Good morning. So, in the last lecture, we have started the features of G6200 Rapier loom, and we have covered some of the features like drive system, warp let-off, warp tensioner, warp stop motion, lobby shading, how the shading is connected that we have seen, jacquard shading we have seen. Then we have seen the slave motion in detail. What is difference between conventional beat up and what is difference between shutterless loom beat up, that is complementary cam or conjugate cam beat up or match cam beat up, that we have covered. Then today we'll start the other features like cloth take up. So how the cloth take up works here motor is there, 5 number cloth take up motor is there. From the belt drive it goes to worm and worm wheel, then gears A gear and B gear, and from B gear it goes to the take up roller, cloth take up roller. So here we can see one spreading roller which spreads the cloth after the fill of the cloth and avoiding wrinkles in it. Then the cloth goes on the pulled by the cloth take up roller and it passes over the two pressure rollers, 3 numbers. So here we can see pressing roller which presses the fabric on the take up roller. Then again the fabric goes to the 4 number, that is what spreader roller, and then the cloth roller is there. So like this the drive is going here. Here we are inserting required PPI in the control panel. Suppose you want 100 PPI, we are inserting this 100 PPI in the control panel, and suppose you want now 120 PPI for the next 1000 meter, we can insert this 120 PPI pix per inch in control panel, and soon the machine will start here with that setting. So no need to change places here. But in previous, if you see, the drive for take up was coming from the sleigh, that is monkey tail lever and a 5 wheel take up motion, and then the take up was there. And if you want to change the PPI, you want to change pinion CP, and you have to stop the machine. But here it is not that completely. It is electronically controlled. We have to insert the PPI on the control panel. The control panel signal goes to the 5 motor and it controls the pix per inch in the fabric. So pressure rollers are there, then spreader rollers are there. So this is what modern take up. The cloth transport operates on the principle of number of pix per centimeter or inch. So this take up is positive and continuous and directly driven by the motor, and it is not a negative or it is not controlled by the other means. So this is what cloth take up. Only the added advantage is that we can enter PPI in the control panel and we can adjust the PPI. So see the cloth take up carefully. Now the next feature is cloth wind up. So after take up, the wind up is also very important. Whatever the fabric is produced at the fail of the cloth, that we have to wind on the cloth roller. But in earlier looms, in the shuttle loom, the drive for the cloth roller was friction driven by the take up roller. But here, the direct drive is given from the motor and it is synchronized with the take up roller. So here the drive comes 3 drive, and here clutch is there. One fixed disc and one movable disc. The clutch is there. The fixed is there and movable is there. So movable is moving forward and backward. More the forward it moves, it touches more to this fixed clutch, and more the drive will be transferred, and the faster this cloth roller will move. So to control the speed of the cloth roller, this clutch system is there. As the diameter of the fabric increases, the clutch system, the more the clutch engages, more this movable can come more closer, movable disc comes more closer to the fixed disc and more drive will be transferred as the diameter increases. So like this, the friction clutch is there, and for the friction clutch, fixed clutch and movable, for the movable clutch from where the drive is coming, that we see. So see the parts here what are there. So this is what drive is coming. So fourth number is what this clutch we can see here, slipping clutch here. From here the drive goes to this gear, and from here the drive goes to this cloth roller. So as the diameter increases, the sensing roller goes backward, goes up, and as it goes up, the sensing roller drive is given to this movable clutch, and it presses. As this sensing roller moves upward, this sensing roller presses this fixed clutch more, and more drive will be transferred to this cloth roller. So like this, as the diameter increases, the sensing roller goes back and more the clutch will be engaged and more the speed of this cloth roller increases. So as the diameter increases, and after 500 centimeter or 570 centimeter, this will be what most backward position of the sensing roller, and this touches this limit switch, and this signal goes to the main motor and the machine stops after the cloth roller has reached 570 centimeter diameter of the fabric. So here the important thing is what clutch drive to this cloth roller. As the diameter increases, more the clutch will be engaged, more drive will be gone. Clutch will less engage means what? The clutch will be away from the fixed clutch, and there is what slippage of this clutch will be there, and less drive will be transferred to this cloth roller. So this is what cloth winder. So see the figure carefully how it works. So this is what weft insertion diagram. Previously also we have seen. So in one weft insertion there are three stages A, B, C. So if you are inserting the weft from left side to right side, there are three stages. So see here how it is. Here is the what cone, accumulator, brake, weft monitoring device, and here are the what weft selector device 1 and 2. Weft selector, two colors it is. Two fingers means, and here is what left hand rapier, and here is a what cutter, left hand side cutter. Only left hand side cutter is present on rapier machine. The cutter on the right hand side is not there, and this is what right hand rapier, and this is what left hand rapier. So how the sequence is there? See here in the figure A we can see the finger is down, A finger is down here, one number finger is down. So weft will be down and the rapier is moving forward. So this weft comes in the path of the rapier. So rapier grips this weft and carries forward. When it is carrying forward, the cutter cuts the weft here. The length of weft hanging between left hand selvage and the selector device. So leading end will be ready here. So here first position is weft gripping. Second position, see here, weft transfer is there. We are transferring the weft from left hand rapier to right hand rapier. Then the right hand rapier, it takes the weft right side, and here as the rapier goes to the selvage, right side selvage, the weft is released here. Three arrows are shown here. So this cycle completes. Now weft has completely inserted and now the beat up takes place. Again the first cycle will start. Again weft grip. Now the beat up has completed now. So we can see here the hanging length is there between selector and tail of the left hand side of the fabric. So again the condition start, again selector comes down, and again the weft is gripped here. When the weft is gripped, here cutter cuts the wefts here. Cutter cuts the weft and leading end is ready now. Leading weft will be ready. So this is what weft gripping position. Weft transferring again here. Weft transfer to the receiving side. Again here beta will be there, hanging length will be there. So says cycle will be what? Repeated. So see the figure carefully how the cycles are there. 3 cycles will be there. So next we can see here weft yarn supply, another feature, and this is also called as accumulator. The function of accumulator is to give unwinding tension of weft during weft insertion constant. Means what? Uniform unwinding tension of the weft throughout the weft insertion. While inserting the weft from left hand to right hand side, the unwinding weft tension or weft tension is kept constant by this whole unit. So what is there in this unit here? This is what supply package, this is what accumulator, this is what brake. So it is like a cycle brake. We can release the brake or we can hold the brake. Release the weld means what? Weft tension will be released. Hold the brake means what? Tension in the weft will be given. So we will see the detailed function of this electromagnetic brake also. So here weft monitoring device is there which monitors weft brake. If weft brake is there, this works on the conductive base principle. If the weft is not there, the signal goes to the motor and motor stops the machine, or motor is not stopping, the clutch get disengaged at the motor and the machine stops. Main shaft will not rotate. So what are the device here? Creel, accumulator, brake is there, weft monitoring device is there. So interesting thing is accumulator here. Accumulator 2 to 3 picks material, that is in the form of coil, we are winding on the drum. So this is what drum. So weft comes here, the fluff catcher is there here, cleans the weft. Here the weft comes in the this hole, and this is what winder. This arrow is winder. It winds the coil on the drum. So one coil will be laid, it will be pushed forward. Second coil will be laid. First 2 coils will be pushed forward. Third coil will be laid. 3 coils will be pushed forward. So 10 coils will be laid. It will be pushed forward, and it comes in the range of this sensor. Laser sensor is there 4. When the first coil touches this laser sensor, this winder stops. So this winder is winding the coils on the drum. The winder stops. So after this, the weft is on the brush. Here the brush is there to clean the weft or to control the balloon size in between accumulator and brake. The brush is there, or brake ring. It is called as what? Brake ring. So this winder works when picking is not taking place, and the winder stops. Coiling of the weft on the drum stops when the picking is taking place. So this is what intermittent motion of the accumulator is there. Start and stop motion of winder is there. So winder works when the rapier is not in the width of the fabric. When the weft insertion starts, this winder stops. The coiling stops. So this is what weft yarn supply. In the next slides, we can see the function of this detailed function of this electronic brake. To see how it is working. Next is color control or weft patterning device, or it is called as weft selectors. In the figure we can see four weft selectors are there. See here, one, two, three, four, and four wefts are drawn through these selectors. Whichever the selector comes down, that weft gets selected. So red color weft, blue color weft, green, white. So you want red color weft to be inserted, the red color finger will come down for that much number of picks. Suppose 5000 picks I want red color. The red color selector will be selected and it comes down. You want white color, this finger will come down in the path of the rapier. So these are what weft selector device, weft selector. So this is what finger, complete linkage is there. This back part is called as tongue. So four selector means 1, 2, 3, 4 tongues are present. On the tongue projection is there. Projection we can see here, tongue is there. And the four magnets will be there. 1, 2, 3, 4 magnets will be there. So we can see here second magnet is selected. Second magnet is selected means what? Second number tongue will come up and it comes in the path of this carriage. So here C type of carriage is there, which is moving forward and backward. Carriage is moving forward and backward. So second magnet gets selected, the second tongue will be get selected, and this tongue comes in the path of this carriage, and the carriage pushes that second number tongue, and second number tongue will be down. So like this, the selection of weft selector takes place, and from the drive for this carriage is coming from the main shaft. So this is what weft selector device. So four fingers, four selectors means four types of colors we can insert. In the rapier we are having 4 to 16 colors. So like this 16 magnets will be there, and now here 4 magnets means 4 color device is there. So this is what weft patterning device. So see the figure carefully. Next is what rapiers here. So this is what in the figure we have shown left hand rapier and right hand rapier. So in the left hand rapier what is there here? So we can see here this is what left hand rapier head, and this is what yarn clamp screwed here. This is what flat spring. So we have to get clamped here. After weft selector comes down, yarn is clamped here, and this complete rapier left hand rapier head is screwed to the flexible tape, rapier tape. So this is what left hand rapier, and right hand rapier we can see here. Here we are having the hook, and fourth number part is here tongue. So this is what tongue is there, and here the spring is there. So clamping pressure is by the spring. So this is what right hand rapier, and here if you press here, the tongue releases the weft, and again it is screwed fitted to the what flexible tape. So rapiers are also called as gripper, left hand gripper and right hand gripper. We can say like that. So gripper and rapiers are same. Don't get confused. So next here, insertion of weft thread. or operating sequence of weft insertion. So how the weft is inserted here. So in the figure we can see this is what cutter unit, bottom cutter and top cutter. Okay. So in this when the weft comes, it cuts, weft is cutted. So first figure we can see here the selector is down. So weft is hanging between your left hand selvage and cone or selector. So this finger down means the left hand rapier is coming forward and it grips the weft here. So you can see your weft is gripped here. After gripping the weft, the cutter cuts the weft here. So leading end will be ready. Leading end of weft will be ready for the insertion of weft. So this is what one number weft is there. So this is what operating sequence of weft insertion. So in this element we have seen additional element is what cutter here. So bottom cutter is fixed, only top cutter is jumping. So bottom part of cutter is fixed. When the weft comes here, the timing cycle we have given at what timing the weft has to cut. So at the time after weft started insertion, the weft has to cut here so that leading end will be ready here. So this is what cycle. Again we will be elaborately we will be saying how the cutter is working in the next slide. You see here. So parts in weft cutter see here. This is what cutter ready position, bottom cutter, top cutter, and this is what retaining hook, and this is what reed on the left hand side of the rapier at the picking side it is. So here we can see here a position, initial position weft selector is down. Okay, now when it is down, this weft is hanging, last inserted pick is hanging here like this. So this weft is down here and this retaining hook maintains proper position of that weft to cut. And here the rapier is gripped, rapier grips the weft, and when this weft moves forward, here the cutter is required here, cutter. So here we can see cutter cuts. See the position, ready position, the cutter is up. When the weft comes here, the cutter cuts and this leading weft is ready now. We insert up to the center of the shade. So this is what weft cutter sequence, properly sequence we should know. And here for the drive for the weft cutter, the top cutter is moving, it is coming from the main shaft. From here in the weft selector device control box, the left hand control box, the drive is coming here. So this is what sequence of the weft cutter or principle of weft cutter. So see here how the weft is inserted. So here we can see here leading end is ready now. So in the weft insertion, three phases are there. Gripping of weft by left hand rapier A. So weft gripping, weft transfer, weft release. So here weft is gripped. Okay, this rapier brings the weft to the center of the machine, center of the fabric. Here right hand rapier goes inside the left hand rapier and it pulls the weft from it, and the weft is gripped to the right hand here. And right hand side it comes, we are pressing the part of the rapier that is here. This part we are pressing here. This part we are pressing, so weft is released on the right hand side. Here it is, the weft will be released. So three stages are there: weft gripping, weft transfer. If proper gripping is not there, weft failure fault will be there in the fabric and the machine stops. And then this is what weft goes to the what receiving side, and here the weft will be released and the beat up of the fabric will be there. Again next cycle starts here. 1, 2, 3. So like this continuous cycle will start. So next year tape drive. So we have discussed this drive. So every machine manufacturer is having its own drive patent, and very important less number of components should be there in the drive. So see here how it is. One driving gear, it is called as driving gear. The drive is coming from the main shaft. Then this is called as stroke crank arm. Then crosshead. This is what crosshead with the transmission lever shaft is there. So this crosshead connected to this driving wheel eccentrically, means this is not connected to the center of the gear, it is connected away from the center by the stroke cam. This is called as what? Stroke cam. So we can move the position of this connection towards the center or away from the center. Stroke, we are adjusting the stroke of the rapier. So this is what the drive comes here, the transmission. So here comes, then here the quadrant drive is there, half gear quadrant, half quadrant is there here, or it is also called as transmission tooth segment. This gives drive to this gear, fifth gear, that is driving gear. Will from fifth the drive comes to the fifth, the drive comes to sixth gear, and then it comes to the tape wheel and tape wheel shaft. So this is what tape wheel or flywheel. So when it moves clockwise, anti-clockwise, so rapier will go forward, backward, and to guide this we are having at the end guide strap. It keeps the tape touched to the toothed flywheel here. Okay, it push, the setting is there. We have to arrange that tightly this guide strap towards the wheel. So how it is moving forward clockwise and anti-clockwise here. So gear wheel rotates. So when gear wheel rotates, as it is eccentric, this is moving third position, crosshead is moving up and down, and the wheel is moving clockwise and anti-clockwise. As the wheel is moving clockwise and anti-clockwise, see toothed gear giving drive to this fifth one. Toothed gear is moving forward and backward, forward and backward. So this fifth gear will move clockwise, anti-clockwise. Sixth gear clockwise, anti-clockwise, and this wheel will move clockwise, anti-clockwise. So like this the drive is going here, and the rapier goes forward and backward, and guiding strip guides the rapier on the wheel. So like this position is called as housing, wheel housing, flywheel housing. So one thing is there, when the width of the fabric is 60 inch, the entry timing is different. And when for the 80 inch fabric, suppose width changes from 60 to 80 inch, the entry point will change. So entry point will change means what? Entry of rapier from left hand and right hand will change. That is called as stroke. So when the width of the fabric is changing, we have to adjust the stroke. Stroke means what? The moment of rapier entry point. So we have to bring this eccentric towards center or away if the width changes. So this is called as what? Stroke changes. So like this stroke change we have to do. So see the rapier drive. So this is what right hand rapier, on the same drive will be there on the left hand side also for left hand drive. So drive is very important to increase the speed of the machine, that is responsible for the speed of the machine. So next here, in the rapier, always the rapier movements are symmetric. Both the rapier should move symmetric, otherwise weft transfer failure will be there. Proper weft gripping will be not there, and proper weft release will be not there. So see here what is happening. What is symmetric rapier travels here? So when 0 degree is there, so these are what 10 positions. A is cloth width. So this is what A is what cloth width. So 1 to 10 positions are there. So 1 to 10 positions. So rapier is ready, left hand side, right hand side. So 90 degrees here, what is happening? Rapier has gone this much inward in the width of the fabric. So that much width, the right hand also come out. So that is what symmetric. 180 degrees here, the rapier has come up to this. Right hand should also come that much distance only. So distance traveled by the rapier at respective degrees should be same, not more or less. If more or less is there, wave transfer will not be there. So see here the 7th position now here. The rapier has come this much inward. Same the rapier has to come this much. So while going back also, see here for 360 this much gone back. So this also gone this much back. So same equal distance it has to go back, same equal distance it has to come in. So this is called as what? Symmetric travel system. So see here at the 180 degree what happens? The left hand also come at this point, right hand also come at this point, and right hand rapier goes inside the left hand and grips the weft, and 90 this right hand rapier is going back. So same distance it has to come and exchange. The symmetric rapier travel is very important, and the setting should be done properly. So see the figure carefully. So next we will see weft thread breaking. So here the break is there, so we can apply the break to the weft. So the cycle brake we have discussed, same brake is there. We can apply the brake to reduce the speed of the weft. We can release the brake to increase the speed. So control on the speed of the weft is by the brake. So we can control the speed. If the speed is not controlled, the weft will be broken and more weft breakages is there. To control the speed, we are having weft thread brake here. So see here how it is working. So here we can see here. This is what the width of the fabric, and this is what weft inserted here. So see here the velocity of weft increases, and when the weft comes to the center of the shade, weft speed reduces. Again weft speed increases, again reduces. So left hand rapier grips the weft. The velocity of rapier increases up to here, and when it comes to the center the speed reduces, left hand rapier. Here from the left hand, right hand rapier grips the weft. When it taking the weft backward, the speed increases, rapier speed increases. Obviously speed of weft increases, and when it reaches to the right hand housing rapier, the speed get reduces. So velocity of the weft is not same, it is increasing, decreasing, increasing, decreasing. So the control of velocity should be there along with the rapier movement. So rapier movement is increasing, decreasing, so same velocity of weft should work, and to work for that we are having the brake to the weft. So see here brake weft. So how the braking phase is there, see here. So this is what center line. Above this AME shows what brake is applied, and L means what brake is released, and S means standstill. So standstill condition is where when the rapier is gripped and ready on left hand side. and right hand side when weft is we are releasing. This is what standstill. So brake is what just holding the weft. Now A is braking phase at the start, braking phase at the middle, braking phase at the end. So braking phase means what? Brake is applied here, here the brake is applied at the middle. So here at the start the velocity increases. So when velocity increases, so here we are releasing the weft, and when the velocity drops we are applying the brake here, applying the brake. Again when velocity increases we are releasing the weft, we are releasing the brake. Again when velocity drops we are applying the brake. So brake is applied, brake is released, brake is applied, brake is released. So whenever the velocity is increasing we are releasing the brake, and when velocity is going down we are applying the brake. So this is for what? So this is for what? To keep the warp with the same taut condition. If this control is not there on the braking, control on velocity will not be there, or either the warp will be tight or loose, and chances of weft breakages will be more. So more number of weft breakages will be there. So applying of brake and release of brake signal is given. These signals we are feeding in the control panel according to the width of the fabric. So signal from control panel goes to the brake, and brake from 0 to 360 degrees. So we can see here from 0 to 360 machine position we are applying, releasing, applying, releasing, applying, releasing according to the velocity of the weft. So we are controlling the velocity also, we are controlling the tight condition of weft also, taut. We are not keeping the weft more tight or loose. So control on weft is proper, and that's why weft breakages is not there. If more number of weft breakages are there in the weft direction, means the brake is not set properly. So proper setting of brake is required here. Otherwise weft breakage and weft failure may takes place. So we'll stop here. So we have completed features like brake, accumulator, then weft color selector device, then drive we have seen, and sequence of weft cutter we have seen, one more feature weft cutter, then take up we have seen, and cloth roller we have completed. So we'll stop here, and in the next lecture remaining features will start.